Welcome to all my dear students. I am Saroj Kumar Sethi of Nalanda Vidya Mandir Science College, Berhampur. So, in our last class, we were discussed about that is classification of matter. That was the first lecture of mine. We have discussed that is classification of matter. Means how a matter can be classified. Matter can be classified into two parts: physical classification and chemical classifications. Once again, I am going to recall you that is matter. It is classified into two parts, that is physical and chemical. In chemical, it is again of two parts, that is pure substance, and from this one, that is mixture. And in this side, it is categorized into three parts, that is this physical classification. Whenever we are concerned with the physical state of matter, then it can be classified into its three states, that is solid, liquid and gas. Similarly, this pure substance from the chemical classification of matter, once again it is classified into two parts, that is element and here it is compound. Element, here it is compound. Compound means it is the combination of two or more elements, atoms of two or more atoms of different elements. So this is the compound. Example we can take, that is water, H2SO4, NaCl, like that. So here the compound water is a purest form. It is the purest form. Similarly, element also, it is the purest form of same kind of element, same kind of atoms. It consists of same kind of atom only, same kind of atoms only. Again, this mixture is of two kinds, that is homogeneous, heterogeneous. Homogeneous means the mixtures which having uniform compositions throughout that mixture. Homogeneous mixture means it is the uniform composition spreading over the mixture, uniform composition of the mixture. Example we can take, that is uniform composition throughout. Uniform composition throughout the mixture, that is homogeneous. Heterogeneous means that is non-uniform. It is non-uniform composition. Example from that homogeneous, that is sugar, water, sugar or salt water, air. These are the homogeneous mixture. Similarly, heterogeneous means muddy water, or we can say that is sand in water, or sand in water, or chalk water, or chalk powder in water. and chalk powder in water. So these are few examples of homogeneous and heterogeneous mixture, and here the pure substance also having two kind, that is two form, element and compound. So again that element, it is of three part. I have already told to you in last class, that is metal, non-metal, metalloid. Metal, non-metals, metalloids. What are the main property of metal? Metals are good conductor of the heat and electricity. That is good conductor of heat and electricity. Here in case of metal it is present, so I have put the tick mark upon the good conductor of heat and electricity. But in case of non-metal it is absent, electricity that is absent. Here in case of metal, brittle, that is ductility and malleability. Ductility and malleability. So in case of metal it is present, but in case of non-metal it is absent. And metalloid, it somehow possesses 50% correct properties of metal and 50% properties of non-metals. If we take few examples, then what will be the examples of metal? Example will be silver, gold, copper, iron, aluminium, etc. In the same way, if you take the examples of non-metal, that will be oxygen, sulfur, phosphorus. Metalloid, that is silicon, germanium, and antimony, that is Sb. So these are few examples which comes under, that is metalloid. So in our last class we were discussed about all these things. Now we are going to discuss, that is physical properties of matter. What are the physical properties of matter? So physical property means that is boiling point, melting point. Physical properties. Physical properties, it means, what are the examples of physical properties? Means it changing some things where the identity or composition do not change. Physical properties means the changing of properties, or those properties where compositions and identity does not change. That is physical property. Example we can take, that is boiling point, melting point, freezing point. So these are few physical properties, and so this, and we can say that is pressure, the changing of pressure. So few physical properties are there where there is no change of composition and identity can be seen. That is physical properties. So these are some physical properties of matter. See, these matters in physical conditions, so we can classify as solid, liquid, gas, but in chemical condition, chemical classification, we can classify into two parts: pure substance mixture. Again, the pure substance, it is elements, compounds. Elements means that it consists of same kind of atoms. Atoms, you have already studied that part, that is the term atoms. I think you might have heard about that term, that is atom, in class 9th. Atom means the smallest part of the matter, smallest part, very tiny particles which present inside that matter, and that cannot be further divisible. Means, for example, this is the matter. This is the matter. Anything we can take that is a matter. Inside it, the component, the basic component of that matter is atom. Means it is the very tiniest particle present inside the matter, that is atoms, which takes part in chemical combination, or we can say that is chemical changeness. So till now, how many total elements are there? 118 elements are there. Out of 118 elements, around 90 elements were found in natural, and other elements were discovering. Remaining elements out of 100 elements, except 90 are discovering in chemistry lab. Okay, so 90 out of 118 are present in natural state, that is natural occurring. So here one thing we need to know, that is, see, before going to that topic, we should know first the basic common things. Atoms, these are the molecules. Atoms are the tiny particles. Am I right or not? It is the smallest particle present inside the matter. Atom, it is the smallest part present in some smallest particle or tiny particle present in matter, which cannot further divisible, which can't further divisible, that is matter. But later on, this definitions getting different, because again that matter, it consists of subatomic particles, that is electron, neutron and proton. But this was the oldest definitions, until now it is valid. Smallest particle present in matter, which can't further divisible, and it takes part in chemical combinations, and it takes part in chemical bonding. We can say chemical bonding or chemical combination. Chemical combinations. This is atom. Molecules means combining of two or more atoms, that is molecules. The higher version of atom, that is molecules. So molecule, example we can take, that is a silver atom, Ag, atom of any kind of element, silver, copper, sodium atom, lithium atoms, etc. Similarly, a molecule, that is combinations of two or more atoms, that is molecules. Molecule means the combinations of two or more molecules, two or more atoms. Examples: O2, H2, H2O, CO2, like that. And compound means it is the combination of two or more atoms of same or different kind. Different kinds, atoms of same and different kind. It means either same kind of two atoms combine to form a molecule, or two different kind of atom. Here in water molecules, one oxygen atoms and two hydrogen atoms is there. Listen carefully, my dear students. One oxygen atoms and two hydrogen atoms. So molecule can be formed by the combination of either same kind of atom or different kind of atoms. So O2 is the same kind of two oxygen atoms. Hydrogen gas is the combining of two same kind of hydrogen atoms, but water molecules having one oxygen atoms and two hydrogen atoms, and CO2 two oxygen atoms and one carbon atom. Carbon and oxygens are different kinds of atoms to each other. So these are the molecules, atoms and molecules. Compounds, if we talk about that is compound, it is the combination of two or more atoms of different kind. So different kind of atoms, when two or more different kinds of atoms are combining, then it forms compound. Examples: carbon monoxide, carbon dioxide, H2SO4, water. Okay, so these are few examples of compound. So these three things, the basic things which you need to know, because you have already studied this, the simplest term, that is atoms, molecules, compounds, ions, radicals. Later on we will discuss one by one, but wherever it is needed I will make you recall, so don't worry about that. So atoms, molecules, compound, I think everybody have clear upon it. Now where we left, from that we are going to continue, that is physical property. So while we are talking about physical property, that is physical properties of matter, means the properties, those properties in which there is no change of identity, that is identity, and that is chemical compositions in the matter, that is physical properties. Means the properties in which anything which takes place, any changes which takes place where the identity and the compositions did not change, that is physical properties. For example, we can take that is boiling point, melting point, freezing point, etc. Okay, so here for physical property, while we are measuring for the physical properties, any kind of physical properties like temperature, some physical parameters like that is pressure, temperature, volume, mass. What is the mass of a particular matter? For example, this is the matter, because this marker it occupies some space and having some mass. So while we are talking about its physical property, means what it looks like, what is the size, what is the mass of that marker. So these are all about, it tells about the physical properties, physical appearance. So the physical parameters of matter like pressure, temperature, volume, mass, etc. we need to understand, that is physical measurement. Okay, physical measurement. So for example, the mass of this marker is 10 gram. So while we are measuring that physical properties, it required some numericals and some units. So now we are going to deal with the units and measurement of some physical property, that is unit and measurement. So while we are going to measure some few physical properties of matter, we will concern about the volume, mass, temperature. For example, what will be the boiling point of this marker, means at what temperature this marker will melt. For example, if it is 400 degrees Celsius, means the temperature is 400 degrees Celsius. Here the 400 it is numerical, it is numeric number, and degree Celsius it is the unit. So for particular measurement of physical properties of matter, it required two things, that is numeric number, numeric means any kind of number, and another that is units. So in the earlier era, three types of units and measurements are revealed, that is for length, mass and time. At initial stage, these three things has revealed its units. For length, that is symbolically it can be represented as m, and the mass is symbolically represented as m, and time it is for, that is t. Time it is t. So different in CGS systems, the units of these three are, that is centigram. Here for the length it is centigram. So centimeter, for length it is centimeter, C for centimeter, G for gram, and S for second. In CGS systems, the units of these three, length, mass, times, are centimeter, gram, second. Similarly, in FPS system, that is, the units of these three will be, that is feet, and P for pound, and S for second. That is FPS systems. In CGS system, that is centimeter, gram, second. In FPS systems, feet, pound, second. Similarly, in MKS system, it will be, that is meter. This is meter, M for meter, and here K for, that is kilogram. That is, in short form we can say, that is kg, and S for second. So in earlier stage, these three types of systems came. After that, the final one, that is international system, that is in SI systems, it came to exist. So all the country, all the internationals, that is organizations, it was bound to follow that one. So in SI system, it will be, according to that international system, that is in SI systems, there were 7 basic units were found. 7 basic units. These are the only 3 up to certain time. But after final stage, according to SI system, that is a international of systems for units and measurement, 7 basic units was that is revealed. And that 7 basic units are SI system of units and measurement. Units and measurement. So 7 basic units of measurement, that is that is 7 basic units. That is first one, length, then mass. Length is it is represented as L, and mass, that is M, then time, that is T, then temperature. Temperature, it is represented as T. So time also represented as small t, and temperature is represented as capital T. Temperature, it is represented as capital T. Then fifth number, after the temperatures, fifth number, that is electric current. Electric current, that is I. Electric current, that means it is I. Then luminous of intensity. Luminous of intensity, that is IV. And the last one, that is amount of substance. Amount of substance. Amount of substance, that is mole. It is represented as mole. If we talk about their units, then units. So these are the some 7 systems. The units will be, for length it will be meter, that is M, and mass it will be, that is kilogram, that is represented as kg, and time is second, that is represented as S, and temperature is Kelvin, represented as K. Electric current, that is ampere, that is A, and luminous intensity, that is candela, and it is represented as CD, and amount of substance, that is mole, and it is represented as mole. So these are the 7 basic units that is revealed by SI system, that is international systems for units and measurement. We have to remember all these things in SI systems. In CGS systems, the basic 3 one, that will be centimeter, gram, second. But in SI system, for the length it will be meter, for mass it will be kilogram, that is kg, and for time it will be second. Now move on to, that is some commonly used physical quantities. Some commonly used physical quantities, that is volume, that is mass. If we talk about that mass, similar word it can be, it is able to hear about the different meanings there in between mass and weight. If we talk about, that is mass and weight, mass means, that is amount of substance. Amount of substance taken, that is mass, whose SI system is kg. SI unit, that is kg, kilogram. Weight also, weight. Sometime when we ask to somebody, that is what is your weight, that person is replying with 75 kg or 80 kg or 65 kgs, that is also kg, but the meaning unit is the same, but the meaning also getting here different, because weight means it is the force due to gravity of the substance. Force acted to the substance due to gravity. Force acted to that substance due to gravity, due to pull of gravity. due to pull of gravity. This is the difference between mass and weight. Similarly, if we talk about the volume, what is the meaning of volume? So why I am telling all these things? Because these are mass, volume, temperature. These are the basic physical parameters. Without it, we can't measure. We can't take that accurate or precisely value for that physical measurement or physical properties. While we are talking about the physical properties, means boiling point, how much boiling point in temperature, that in Kelvin or in degree Celsius, means we should know that what will be the units in SI system or in CHSE systems or whatever it is, in any systems. We should know the unit and measurement. That's why I am telling all these things. So volume means it is the space occupied by the substance. It is the space occupied by the substance. For example, a cube is there. A cube is there. Do you know how does the cube look like? The cube is look like in this way. This is cube. This is cube. Okay. So here three parameters are there. That is, what is that? That is height. It is the height, and it is the length. That is L. It is height. It is height H. It is the length, and it is that is breadth. So the volume will be that. What is the volume? Length into breadth into height. That is L cube, or we can say length cube. Length cube. So if we take that is SI unit of length, that is meter, then what will be the volume? What will be the unit of volume? That is meter cube. Meter cube is the unit of volume. So in SI unit of volume, it is meter cube. That is meter cube. That is meter cube. Okay, this is the SI system, SI unit of volume. Similarly, if we talk about the density, density means this is another thing we are going to talk about. That is density. Density means that is mass by volume of any substance, of any matter. Mass by volume. So what is the SI unit of mass? That is kg. And the SI unit of that is volume, that is meter cube. Meter cube. So it will be kg per meter cube. Kg per meter cube is the unit of density. Similarly, if we talk about that is temperature. Here in temperatures, three different scales have been used for the temperature. For that is a temperature. Temperature is used for the measurement of heat. It is used for measurement of heat. Measurement of heat. Am I right or not? So temperature is measured in three scales. That is in degree Celsius, in Kelvin, and in Fahrenheit. In Fahrenheit. So here 0 degree Celsius, that is 0 degree Celsius, it will be 273.15 Kelvin temperature. So while we are talking about the conversion of degree Celsius to that is Kelvin temperature, means whatever the degree Celsius we are taking, if we add 273.15 to that temperature which having degree in Celsius, then we will get in Kelvin temperature. For example, water having, for example, water boils at, water boils at 100 degrees Celsius. So 100 degrees Celsius means if we convert it into Kelvin, then what will be the value? Means whatever the degree Celsius is there, that amount of degrees Celsius is there, plus 273.15. So it will be 373.15. So if we convert it into Kelvin, it will be 373.15 Kelvin of temperature. Am I right or not? Similarly, again one that is other scale is there, that is Fahrenheit. While we are talking about the conversion of degree Celsius to Fahrenheit, one formula we need to know, that is Fahrenheit. So Fahrenheit can be calculated by, that is the formula 9/5 into that amount of degree Celsius temperature plus 32 degree. So this is the formula. If for in place of degree Celsius, if we take for that is 37, that is body temperature, 37 degrees Celsius, if for this place, that is for degree Celsius place, if I take that 37 degrees Celsius, means by calculating what will be the Fahrenheit we will get, it will be around 98.6 Fahrenheit, which is our body temperature. Above that we will feel fever. That is above the 98.6 Fahrenheit we will feel fever. Similarly, if we take 40 degrees Celsius in place of here, 40 degrees Celsius means 5 8 ja 40, so 8 into 9, 72 plus 32, it will be 104. So for 40 degrees Celsius the Fahrenheit will be 104 Fahrenheit. For 40 degrees Celsius, if we take here 40, means that is 9 divided by 5 into, in place of degree Celsius, that is 40 plus 32. Here 5 8 ja 40, 72 plus 32, it will be 104 Fahrenheit. Similarly, 25 degree, that is the standard temperature. 25 degree atmospheric temperature, 25 degrees Celsius means in Fahrenheit it will be 77 Fahrenheit. So these are the interconversion of degree Celsius to Fahrenheit. It is very much important. One more question it may ask for your exam. So for this lecture, this much only. On our next lecture we will discuss about significant figure and scientific notation. Okay.